Number 4, we are doing completing the square. When you do completing the square, you're trying to find the value on the end that is a perfect square, that when you factor it out, it factors into the same two factors twice. So how we complete the square is we're going to take half the middle coefficient squared. My E doesn't look very good here. Coefficient. Still doesn't want to write. So in this case, I'm going to do half of negative 12. Half of negative 12 is negative 6. I'm going to square that. That makes that a positive 36. So in there, I'm going to have a 36. What is that meaning? It means that if I have x squared minus 12x plus 36, and I factor it out, factors of x squared, x and x, my signs, since the end is positive, both the same as the middle, negative and a negative, factors of 36 that add up to 12, 6 and 6. So I get x minus 6 squared. So I've made this into a value that makes the expression a perfect square when I factor it out. So number 5, I'm going to fill in the blank to make the expression a perfect square. I'm going to take half of my middle coefficient, which is 10. So half of 10 is 5. I'm then going to square that number. 5 squared is 25. So the number here on the end should be 25. If I have y squared plus 10y plus 25 and I factor it out, I'd have y and y. Since the end is positive, they're both the same as the middle, which is also positive. And factors of 25 that add up to 10, 5 and 5. Sure enough, it factors out into a perfect square. Number 6, fill in the blank to make my expression a perfect square again. I'm going to take half of my middle coefficient. This time my middle coefficient is 2. Half of 2 is 1. And then I'm going to square 1. 1 times 1, still 1. So that's going to be a 1 in there. And you could factor it out if you want to, but trust me, it should work. So number 7 says applying the quadratic formula. Looks like those problems when we had a quadratic equation, one with a squared term, that we tried to solve by factoring because it was set equal to 0. However, try as hard as you can on this one. You probably will not be able to get it to factor because it's going to come out to some really strange answer. So somebody came up with the quadratic formula to solve a quadratic equation. By the way, you can use the quadratic formula to solve the ones that do factor also. Usually factoring is easier to do, and that's why we do factoring first. Quadratic formula says if we have an equation in standard form, ax squared plus bx plus c equals 0, then x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I go over here to my quadratic equation. My a value is the coefficient of the x squared term, so it's 5. My b value is the coefficient of my x term, so it's 9. My c value is my constant term, so it's 2. Be careful if there's a negative in front of those, then I include the negative with my number. All of mine are positive on this one. Now I'm going to plug it into my quadratic formula. So I'm thinking about when I plug in for a value, I put it in parentheses. Minus the b value plus or minus the square root of the b value squared minus 4 times the a value times the c value over 2 times the a value. Notice I didn't put my numbers in there yet because I want to point out anywhere I have a variable I'm going to plug in and I'm going to put it in parentheses. So minus the b value. The b value is 9. Plus or minus the b value squared. The b value again is 9. Minus 4, which is part of my equation, times the a value, which is 5, times the c value, which is 2, over 2 times the a value is 5. So I've plugged all my numbers in. Now I want to simplify this. Since I have minus 9 here, I can drop the parentheses. It's just minus 9 then. Plus or minus the square root of 9 times 9. 9 squared, 81. Minus 4 times 5 times 2. Minus 4 times 5 would be minus 20. Negative 20 times 2 is minus 40. All over 2 times 5, which is 10. I'm then going to do my subtraction underneath my square root. So I have negative 9 plus or minus the square root of 81 minus 40, which is 41, all over 10. Now on the ALEKS program, they're going to make you put that in as 2 separate answers. There's not the plus or minus option. So when you put it in, you're going to put in negative 9 plus the square root of 41 over 10. Notice my negative is on top of my fraction. And then you're going to put negative 9 minus the square root of 41 all over 10. What I do is I use your word shortcuts. If you highlight this and hit Control C, that copies. Then if you go over here and hit Control V, it pastes. Then you just need to change the middle sign from a plus to a minus, and you don't have to retype the whole thing. Be careful when you're typing it in. Since this all goes on top, hit the fraction button first. Type the top in separately from the bottom, and that works easiest. Otherwise, you have to highlight that to underline the whole thing to make your fraction. But both answers look something like that. I'm going to add some more space here. So number 8, again, it wants us to use the quadratic formula to solve for x. So again, my quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So on this one, a is going to equal 9, b is going to be a negative 5, and c is going to be negative 1. So I'm going to plug those into my quadratic formula. Minus the b value. The b value is negative 5. Plus or minus the square root. The b value squared. The b value squared, so negative 5 squared. Minus 4 times the a value and times the c value. The a value is 9, the c value is negative 1. All over 2 times the a value is 9. So plugged in my numbers for a, b, and c. Now I need to simplify. On this one, we have minus a negative 5. Minus a negative 5 would make that positive 5. Plus or minus the square root of a negative 5 squared. Negative 5 times negative 5 should be positive 25. If you put this in your calculator without the parentheses, you're going to get the wrong sign, so be sure you use the parentheses if you have to use your calculator. Negative 4 times 9 would be negative 36. A negative 36 times a negative 1 going to be positive 36 then. Over 2 times 9, 18. So on this one here, we're going to add. We're going to get 5 plus or minus the square root of 25 plus 36, which would be 61, all over 18. So again, you're going to have your 2 different answers. X is going to be 5 plus the square root of 61 over 18, and 5 minus the square root of 61 over 18. Make sure that fraction bar goes under everything on the numerator, not just under the 61. Goes all the way across. So not so bad once you get the numbers in and you know where everything goes. Let's try one more of those. Number 9. Number 9, again, we want to use our quadratic formula. I like to write big, so I'm going to add a little more space to our paper. You don't have that option, but maybe by the time I print them out next time, there'll be plenty of room. So my quadratic formula again. x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So a in this case is going to be 3, b is also going to be 3, and c is going to be negative 7. So plugging those into my quadratic formula, I'm going to have minus the b value is 3, plus or minus the square root of the b value squared. The b value is 3 again, minus 4 times the a value times the c value. A is 3, c is negative 7. All over 2 times the a value is 3. So simplifying, here we get minus 3 plus or minus the square root. 3 squared, 3 times 3 is 9. Negative 4 times 3 would be negative 12. A negative 12 times a negative 7. Negative times a negative is a positive. 12 times 7. 84. Over 2 times 3, 6. So again here, since we had a negative times a negative, we had a positive, we're going to add. So we get negative 3 plus or minus the square root of 84 plus 9 would be 93 over 2 times 3, which we already did, was 6. And so we get our two answers. X is going to equal negative 3 plus the square root of 93 over 6, and negative 3 minus the square root of 93 over 6. And both of those two things have to go in for my answer. Now there are some equations where once you have your square root, you can simplify your square root. Right now in intermediate algebra, they don't make you simplify it. It'll say it's correct. However, you could have simplified it into this. So if you want to practice doing that, you can. Once we get into college algebra, we'll worry more about trying to simplify our radicals. But in this case, if you can get it this far, we're going to call that good enough. Number 10, 11, and 12 have to do with finding the discriminant of your quadratic equation. So when you have your quadratic equation, negative b plus or minus the square root of b squared minus 4ac all over 2a, the part that is underneath the square root is your discriminant. Smush that in there. The reason they call that the discriminant is because if you have the square root of a positive number, you're going to get two solutions. Right? If that's the square root of 10, I'm going to have plus the square root of 10 and minus the square root of 10. If you have the square root of 0, you're only going to get one solution. Because I'd have plus or minus 0, well, something plus 0 and something minus 0 give you the exact same number twice. So it's really only one solution. And if you have the square root of a negative number, you get no solutions because we can't take the square root of a negative. It's an imaginary number. So what they're going to have you do is find the value of the discriminant, find this part underneath the square root, and then say how many solutions do I have then if that's the number that's under the square root. So when we do the discriminant, we're only doing the b squared minus 4ac part of it. So again, a would be negative 5, b in this case is negative 1 because a negative x is a negative 1x, and c would be negative 4. So I want to do b squared, negative 1 squared, minus 4 times the a value, which is negative 5, times the c value, which is negative 4. So, negative 1 squared, negative 1 times negative 1, positive 1. Again, if you're using that calculator to do that, be sure to use the parentheses. Negative 4 times negative 5 is positive 20. 20 times negative 4, negative 80. 1 minus 80, negative 79. So the value of our discriminant is negative 79. If that number under the square root is negative, we can't do it, and so we're going to get 0 solutions to that problem. Now hopefully you wrote all this stuff down, because I don't want to write it down a whole bunch. And I'm going to go to number 11 here. So number 11. Again, I'm just going to add a little more space. And so calculate the discriminant, determine how many solutions. So I'm going to do the b squared minus 4ac part of it. A is going to be 2, B is going to be negative 6, and C is going to be positive 1. So b squared, negative 6 squared, minus 4 times the A value, which is 2, times the C value, which is 1. Negative 6 squared, negative 6 times negative 6, positive 36. Negative 4 times 2 would be negative 8. Negative 8 times 1, still negative 8. So 36 minus 8, going to be 28. My discriminant is a positive 28. If I have a positive 28, that means I'm going to have plus or minus the square root of 28, which means I'm going to have 2 real solutions. Number 12, same thing. I'm just going to move it up so it's a little easier to see and add a little more space. So number 12, again, we're computing the value of the discriminant, giving the number of real solutions. So the discriminant, b squared minus, b squared minus 4ac. B in this, or A, gosh darn, where am I going today? It's Monday. A is going to be negative 4, B is also negative 4, C is negative 1. So b squared, negative 4 squared minus 4 times the A value, which is negative 4, times the C value, which is negative 1. So negative 4 squared, negative 4 times negative 4, positive 16. Negative 4 times negative 4 is 16. 16 times negative 1 is negative 16. 16 minus 16 is 0. So the value of our discriminant is 0. That means we're going to have plus or minus the square root of 0, which is just a plain 0. That means I'm only going to have one solution, whatever the first part of my quadratic formula is, but I'm only going to get one real number because I get the same number twice. And the last 3 problems on your pie chart, 13, 14, and 15. Solve an equation that uses the odd root property. So we talked about in the very first ones on this page having the square root property, where if I was squaring something, I have to do the opposite of squaring, which is taking the square root. Here we're going to do cubed roots. U cubed equals 4. Now when we do the cubed root of both sides, if I do the cubed root here and the cubed root here, the cubed root cancels out a cubing because they're inverse operations, so I get u equals the cubed root of 4. Now with cubes, the plus and minus thing doesn't hold true, because if I cube something, 4 times 4 times 4 is a positive number, but negative 4 times negative 4 times negative 4 is a negative number. So we're only going to get one solution. Again, I would want to simplify this if I could, but when we simplified cubed roots, we said 2 cubed is 8, 3 cubed is 27, 4 cubed was 64. Obviously all those numbers are too big. I can't simplify this one. So my answer is just going to be the cubed root of 4. Now if I'm going to do the next one, b cubed equals negative 12. Again, I'm using that property that I have to do the opposite of cubing, which is taking the cubed root of both sides. So V is going to equal the cubed root of a negative 12. If there's a negative out in front, what they're going to do is say that I have the cubed root of negative 1 times 12. Again, the 12 I can't factor into anything that's a perfect cube, but the cubed root of negative 1 is negative 1, because negative 1 times negative 1 times negative 1. So if there's a negative underneath, what's going to happen is they're going to take that negative out in front and make it negative cubed root of 12. So cubed root of negative 1 is negative 1. I don't really need the 1 there. And so instead of this form, this is going to be the better form for my answer. V equals negative cubed root of 12. So just keep in mind, if there's a negative in there, to move the negative, put it out in front instead of underneath your radical. And the last one, I'm going to change that problem just a little bit because I want it to be one that you can simplify. So if it's not already changed, let's make that a 24 instead of a 21. So number 15, u cubed equals negative 24 because I changed it. I'm the teacher, I get to do that. So if I'm going to simplify this, I'm going to do the cubed root of both sides. And so u is going to equal the cubed root of negative 24. Negative 24. Again, since this one has the negative on the inside, we're going to rewrite it as u equals negative the cubed root of 24. Now this is one you can simplify. Remember I had that list before, 2 cubed is equal to 8. So I can factor 24 into 8 times 3. So I have negative the cubed root of 8 times 3. The cubed root of 8 is 2, because 2 times 2 times 2 is 8. So that 2 is going to go out in front. I'm going to get negative 2 times the cubed root of 3 then for my answer. So I wanted to have one of those that you could simplify. Most of the time, if it's a cubed root, 8 is the most common one that's a perfect cube. But keep in mind, 27 is also a perfect cube. 64 is also a perfect cube. So if it has any of those factors, I want to simplify as much as possible. And so I need to simplify it by taking out the cubed root of 8. And that is the end of your pie chart.